Good morning. I'm Jean-Louis Van Belle. I've posted a few videos before. Don't know if you watched them. Doesn't matter all that much. But yeah, I have some papers on physics mainly, some theories. Today I'm gonna do something really short. Probably answer some basic questions. Probably the same questions that you have when you are listening to me, about philosophy and physics. Um, Really basic questions, actually. I think many people, are attracted to, quantum physics and modern physics. They want to study it because they're a little bit dissatisfied with, the philosophical answers to, these existential questions that we have. What's reality? Who are we? How do we fit in? How, consciousness is such a strange experience, self-consciousness. So we have our mind. Is there stuff outside of our mind? What is real? What is not real? I'll be very pragmatic, actually. When you ask, what is real, what is not real, you need to think about that philosophical concept, reality, and this is a philosophical concept, and like many others, it's useful to sort of think like, if we want to define this, we probably should define it also by saying what it is not. When you think of reality, and what is non-reality, non-reality probably would define it as something that exists in our mind only, like a dream. A dream is not real. We know that. Well, a dream is defined as such, in a sense it is real because it happens in our brain when we sleep, and so a dream in that sense is real. So, but yeah, generally in our common everyday language, we would say reality is probably, the things that which does not exist in our mind only, something that has some independent existence outside of our mind. And there's plenty of examples there, because yeah, I'm talking to you, you're listening to me, so we know you are there, I am here. And then we have so many things that are there, independent of your individual or my individual thinking of our mind. And at the most basic level, we have matter, right? And yeah, we also have non-matter. We have light and matter, and then these are the most fundamental things, right? Molecules, atoms, electrons, and then light consists of photons, we know. So, and then we have a lot of experimental facts that establish all kinds of relationships and show us how, matter particles interact with light. And so I put a few actually pictures or images there, illustrations beneath that show, what reality is, I guess. But the first one is Thomas Young. At the end of the 18th century, he established, that light has a wave, a wave-like nature, a wave-like character, and I put it there because people often forget. Now it's so obvious that light is a wave, an electromagnetic wave. But in a sense, Newton thought light was like a beam of particles. So Newton, the same Newton from the apple that fell from the tree. So Young was a revolutionary when he established these diffraction interference patterns. Using a paper card, and then some light that came through his curtain, and so he saw these diffraction patterns on the wall. And he said, no, light is a wave. In the meanwhile, we know modern physics established some kind of it's not a compromise. It's actually the real description of light. Light both has a wave-like character and a particle-like character, and we have a very consistent. I mean, it's not easy to express in words, but the quantum mechanical equations, the Planck-Einstein relation and all that, they give a very consistent mathematical description of what light actually is, and so I'm happy with that because that sort of tells me I have an idea what light is, and I also have an idea what electrons and protons are because of, these two guys in the middle there, Davison and Germer. They fired electrons at a crystal and found, electrons, matter particles in general. We thought of them as like kind of bullet-like things, but they're not. They also they have a wave-like character, and we have these double slit experiment of electrons, and other, with molecules we have it. So matter is the same thing. It's wave-like, and it's particle-like, and that's very confusing, probably, but I feel comfortable with it in the sense that, I've looked at these equations. It makes sense to me. I understand Schrödinger's equation, this and that, Maxwell's equation. After a while, you get really familiar with that description of the world, and you feel, yeah, I know what light is, I know what matter particles are, and for that we have to thank, a number of other eminent scientists, physicists, and I put two of them there, Arthur Compton and Werner Heisenberg, together with, of course, Schrödinger and Dirac, etc. I mean, Compton, he really he modeled the interaction between electrons and light, between matter particles and light. So we have the Compton wavelength or the Compton radius of an electron, and that all makes sense. And Heisenberg, of course, has that then, that matrix mechanics, and then Schrödinger then came up with wave mechanics. In any case, the point is here that, these three illustrations below show us that modern physics gives us answers that philosophy cannot give us. They give us a description of a physical world that is out there, and that the description is very precise and very accurate. So so I would say that's reality. What these guys are measuring and establishing, and what they have found, that's reality. So what question remains then is probably philosophical questions, like when we do these experiments, we measure lengths, for instance. We measure a size of something, and we measure a frequency. So that's sort of time interval, the period of a fundamental oscillation. I mean, if you look at my papers and stuff, you'll see that matter particles, basically, you need to understand them in terms of a fundamental and elementary oscillation, and that's given by the Planck-Einstein relationship. In any case, I won't go into the detail, but the question that sort of lingers on a little bit is, space and time. These are concepts we use when we do these experiments, when we establish the facts, but are they real, or is space and time, is that something that exists in our mind only? My answer to that question is space and time, is that real? Is a bit the same as the question I started out with. What is reality? What do you mean when you say space and time is real? Of course, when you do these experiments, you do establish some kind of space and time acquire some kind of physicality, right? An electron takes up some space, and space becomes then something else than that Cartesian vector space, mathematical space that exists in your mind only. No, a planetary system, or the galaxy, or the whole universe, that makes that makes space something physical, and that's the funny thing with relativity theory. Relativity theory, special and general relativity theory, tells us things are relative. Your clock will run faster or slower depending on the gravitational field, the strength of the gravitational field that you are in, or your motion relative to some other observer that is doing, or measuring some stuff. So time and distance, the clock and space, it's relative, but at the same time, it's very physical, because we describe our worlds using these concepts, and measuring the fundamental period of a particle. That's a physical thing. So I think the question is more like, is it real, not real? I don't think that question matters really. Of course, these things are real. Time, distance, mass, force, energy, momentum. These things are all very real. We apply a force to an object, and it will give it some acceleration. But the thing that modern physics tells us, that Einstein told us, and that got confirmed by experiments by many other scientists afterwards, is that these concepts are relative. They depend on your frame of reference. They do depend on the fact, or you live in empty space, or you live on the surface of a huge planet with a very strong gravitational field. Then things that will affect how you measure time and distance and how you do your experiments. The nice thing though is that and that sort of saves us. These concepts are relative, but when we combine them with nature's constants, then we get, your description of the world is not going to depend on your frame of reference. A Martian who's flying around at 0.8 times the speed of light in a spaceship and is doing quantum mechanical experiments or measuring the speed of light, he will find Planck's quantum of action as a fundamental constant in nature, and he will find that the speed of light is the speed of light, is the same. It's a very weird and non-intuitive thing, but that's what it is. Speed of light is the speed of light everywhere. It's the same constant, 297,000 something meters per second. And the elementary charge is the elementary charge. A proton and an electron, in that fast traveling spaceship is, not 0.8 times the elementary charge. No, it's the elementary charge. An electron is an electron there, and it's an electron, for me and for that Martian and for somebody who lives in Jupiter. Elementary charge is the elementary charge. So we can combine these relative and absolute notions, or are they categories of the mind? I wouldn't say so. Because that's a bit of a philosophical concept. But these notions, at least, we have relative and absolute things there. And but when we combine them in, when we do these experiments, we can derive, there's going to be a Maxwell living on Mars, and Maxwell's equations are going to be, some other guy's equations, but they're going to be the same equations. And that's something very, very, fundamental. And Schrödinger's equation, that does not depend on your frame of reference, and that's where we can establish, or can probably communicate if we show Schrödinger's equation. The other guy may use other mathematical symbols. The Martian we meet when that spaceship finally arrives here and he gets out. We'll show him these equations and he'll come out probably because he's traveling in a spaceship with pretty much the same equations using other symbols perhaps, but he will surely recognize that. He should. At least that's what our experience is telling us, because this description does not depend on your frame of reference. And so we have the Planck-Einstein relation there, and the Broglie relation, lambda, the wavelength is Planck's quantum of action divided by the momentum. I put it as a vector equation there. But in any case, I won't go into any detail, but that's the answer to the question, really. What's reality? Well, it's, what's being described by a modern physicist, and that's why guy like Richard Feynman and all that, he didn't like philosophers because they don't get their hands dirty and get into that, and then into the math that you need to sort of understand these equations. But for me, that's a pretty consistent description of the world. And that's sort of where I answered, and I did not answer the question, what is reality? I'd rather talk about the world, what is the world? And that's where, if you want a philosopher, I'm not going to quote Immanuel Kant, who says time and space, there's the categories of the mind, they exist in our mind only. No, I think that's bullshit. Wittgenstein was closer to the mark. I mean, he's not my favorite philosopher because he wrote around the same time. I mean, even after Einstein had published his relativity theory and this and that, and he wasn't really, apparently he wasn't aware of that scientific revolution that was taking place. But at the same time, I think his description of the world as what I put there, die Welt ist die Gesamtheit der Tatsachen, nicht der Dinge. So in English, that's the world is the totality of facts. It's not stuff. It's not things. It's not concept, nicht der Dinge. Yeah, that's pretty much that's a good description, I think, of reality. So we establish facts by experiments, by in our experience. We and then the world, our world, is the totality of those facts. And that's it. I hope you enjoyed this very, very short presentation on very fundamental concepts. It's short, but I think it should be short because I would say don't study philosophy. Get into get yourself a good book of physics, or read my papers and look at my other presentations, and then probably you'll feel much more comfortable with, answering that question. What is reality? What is real? What is not real? And many other philosophical questions that come with it. All right. Thank you very much, and hope to see you around. Bye.